So, the Atlas of North American English. Although it's been 15 years since it was published, it's still the baseline for current research in North American dialectology, in the sense that most recent research in North American dialects is situated in the context of the dialect regions and sound changes that the Atlas documented. And a lot of isoglosses in the Atlas are defined in terms of formant value benchmarks. So for example, the Northern City shift involves the fronting of lot and the raising of trap and so on. And for the purpose of defining isoglosses, the Atlas operationalizes the raising of trap specifically as meaning speakers whose normalized mean F1 of trap is less than 700 Hertz. And the fronting of lot is speakers whose F2 of lot is greater than 1450 Hertz. And these numerical benchmarks are used for drawing isoglosses. Another example, this isogloss, which reaches from Rhode Island down to Baltimore, is based on the raising of thought, and specifically the raising of thought to F1 less than 700 Hertz. And then other research often uses the benchmarks defined as the Atlas specifically as a point of comparison. So like we've got Becker 2014 using the 700 Hertz cutoff to judge whether or not thought counts as raised, Roeder 2009 using the 700 Hertz cutoff for the Northern Cities shift, Brumbaugh and Copes 2017 use a variety of benchmarks defined by the Atlas, and so on. So these benchmarks function as a sort of de facto standard of comparison that gets applied to new research. But here's the thing, those benchmarks are defined in the Atlas on the basis of mean normalized formant measurements. And the way formants are normalized in the Atlas is not necessarily the same as the way formants are normalized in a lot of more recent research, and different methods of normalization produce different results. So if you want to use a benchmark like F2 greater than 1450 Hertz, but your formants are normalized by a different methodology than the Atlas, how sure are you that 1450 Hertz represents the same degree of fronting in your data as it does in the Atlas? So let's talk about it. The Atlas uses formant extrinsic log mean normalization. What that means is just that we abstract away from the differences between speakers by scaling formant measurements so that all speakers have the same geometric mean, which comes out to about 989 Hertz. So here's an example. Here's Zara, a speaker who I interviewed in Cooperstown, New York. These are her formant measurements. And the geometric mean of all of her F1 and F2 measurements happens to be 1105 Hertz. So to get to the Atlas normalization, all we have to do is bring her geometric mean down to 989 Hertz instead, which means just multiplying all of her formants, F1 and F2, by the same scaling factor, multiply them by 0.895, bring the geometric mean down to 989. So when the Atlas gives benchmarks, this is the normalization method that it's presupposing. Both formants are scaled uniformly so that the speaker's geometric mean is 989. That normalization method is not super common in more recent research. In most recent sociophonetics of American English, formant measurements are normalized by the Lobanov methodology. That might be because Lobanov gets the best rating in Adank et al.'s comparison of normalization methods, might be because the FAVE software package uses Lobanov-Normalization for normalizing its vowel measurements. Anyway, like if we look at papers in the journal Language Variation and Change since 2015 that use normalized vowel formants, 54% of them use Lobanov, which is more than 3 times as many as any other normalization method. In American speech over the same period, 61% of vowel normalization is done by the Lobanov method. Looking at NWAV abstracts since 2015, 72% of the ones that mention a specific normalization method in the abstracts use Lobanov normalization. Lobanov is the predominant normalization method in North American sociophonetics at this time. And some of these papers using Lobanov normalization want to compare their measurements to those Atlas benchmarks. So how does Lobanov normalization work? Well, instead of normalizing formants to a standardized geometric mean like the Atlas normalization does, Lobanov normalization is based on arithmetic mean. And it normalizes F1 and F2 separately instead of scaling them together. So Lobanov normalization normalizes each formant in terms of z-scores. So you calculate for any given token produced by a given speaker, how far away it is from that speaker's average value of a given formant, measured in units of that speaker's standard deviation of all tokens in that formant. So for example, let's go back to Zara's measurements again. Her overall mean F1 of all tokens is 745 with a standard deviation of about 150. So if we look at this token over here, that token is 1.37 standard deviations below the mean. Similarly, her mean F2 is 1695 hertz with a standard deviation of 270. And this token down here is about 1.19 standard deviations forward from the mean. So in Lobanov normalization, the F1 value of this token is 1.37 units, and the F2 value is 1.19 units. Now, the first thing to point out is that Lobanov normalization and log mean normalization can produce conflicting results. They can disagree on comparisons between speakers. So for example, here's two speakers from the atlas, log mean normalized, the way they appear in the atlas. If we want to use a benchmark for like 700 hertz in F1 for the raising of trap in the Northern Cities shift, well, according to that benchmark, Ernest has raised trap and Gordon doesn't. Obviously, that's not true, right? Ernest's trap is actually near the bottom of his vowel space, and Gordon's is on par with his other mid vowels. It's just that Ernest's vowel space is a lot shorter from top to bottom than Gordon's is. So for Ernest, 700 hertz is a low vowel, and for Gordon, 700 hertz is a mid vowel. Now, this is log mean normalization. Lobanov normalization normalizes each formant separately, so it factors out the difference in shape between Gordon and Ernest's vowel spaces. Under Lobanov normalization, Gordon has a higher trap vowel than Ernest. So, you can see why maybe if people want to use atlas benchmarks, they might want to use atlas benchmarks on Lobanov normalized measurements. But how do we define those benchmarks? There's no one Lobanov normalized value that's equivalent to 700 hertz in atlas normalization. The two methods aren't directly comparable. So if we want to compare Lobanov normalized data to atlas benchmarks, how do we do that in a responsible way? What benchmarks can be set in Lobanov z-score units to represent, for example, roughly the same degree of height as 700 hertz represents in the atlas normalization? So here's what I propose for converting atlas benchmarks into benchmarks that make sense in Lobanov normalization. The benchmarks are defined based on the regional features of the normalized measurements of the atlas data. Lobanov normalization is based on z-scores. So what we're going to do is we're going to use the z-scores of the normalized atlas data. Here are the log mean normalized formants of all 132,000 vowel tokens from the atlas data. The mean F1 of this 132,000 tokens is about 650 hertz with a standard deviation of 150. The mean F2 is 1,595.5 with standard deviation 435. So now let's see where the atlas benchmarks sit with respect to the overall atlas data and convert those into z-scores. And those z-scores are going to be our Lobanov normalized benchmarks. So for example, the atlas benchmark for the fronting of lot is 1,450 hertz. That's 145 hertz backer than the mean, which is to say it's about a third of a standard deviation backer than the mean. So the Lobanov transformed benchmark for the fronting of lot is about minus 1/3 in z-score units. Similarly, the atlas benchmark for the raising of trap is 700 hertz, which is 0.329 standard deviations lower than the mean F1 of the entire corpus. So the Lobanov transformed benchmark for trap raising is 0.329. So if we want to take the Lobanov normalized formant measurements and we say, well, Gordon's trap vowel is higher than that 0.329 benchmark and Ernest's isn't. So Gordon meets that Lobanov transformed benchmark and Ernest doesn't. Now, I'm obviously not the first person to propose a transformation like this to make Atlas benchmarks usable with Lobanov-normalized data. Brumbaugh and Copes did something very similar, and they did it based on the z-scores of their own corpus. But if we're going to agree on standardized benchmarks that are appropriate for comparison across studies, they should be based on the z-scores of the Atlas data, since after all, that's what the original benchmarks were based on. Now, again, transforming the benchmarks in this way does not mean that the same speakers who have TRAP higher than 700 Hertz in log mean normalization are also going to have it higher than 0.329 in Lobanov normalization, right? It just means that Lobanov 0.329 represents about the same degree of raising relative to the overall distribution of the corpus as 700 Hertz does. But the two normalizations can still disagree about which speakers meet which benchmarks. So if this transformation of benchmarks doesn't actually pick out the same speakers as the original benchmarks, how do we verify that transforming benchmarks in this way gives us values that are actually useful for evaluating dialect features? Well, the Atlas uses benchmarks to define the isoglosses that determine dialect regions. So for example, the Inland North is defined in part as the region with TRAP higher than 700 Hertz. So we can ask, do the Lobanov transformed benchmarks do as good a job of defining the Atlas's dialect regions as the original benchmarks do? Well, the Atlas defines three parameters for evaluating isoglosses. Homogeneity, which is what percentage of speakers inside an isogloss meet a given benchmark. Consistency, which is what percentage of the speakers who meet a given benchmark are located inside the isogloss. And leakage, which is what percentage of speakers outside the isogloss meet the benchmark. Ideally, you want isoglosses to have high homogeneity and consistency and low leakage. These are the parameters that are used by Lebov, Ash, and Boberg for choosing the benchmark values. So what we're going to do is we're going to look at the regions that are defined by the benchmarks. We're going to see if the Lobanov transformed benchmarks, as I've defined them, are as effective at characterizing the regions as the original benchmarks are. For simplicity, I'm only going to be looking at the numerical formant benchmarks. I'm not going to be looking at other isogloss criteria, such as whether or not the Cot-Cot merger is present. And I'm going to be looking at the main dialect regions as the isoglosses defined by the Atlas. I'm using a data package compiled by Joe Fruwald that contains calculations of Lobanov normalization for each speaker in the Atlas. So, okay, for example, the regions of the Inland North, including the St. Louis corridor, is defined in part by the benchmark F1 of TRAP is less than 700 Hertz. So there are 71 speakers in the Atlas data in that region. 53 of those speakers have TRAP this high in the Atlas normalization. So the homogeneity of that region with respect to that benchmark is 74.6%. Similarly, we can calculate the consistency and leakage of the region with respect to that benchmark. We have 49.5% consistency, 14.8% leakage. Now, if we use the Lobanov transformation of that benchmark, TRAP less than 0.329 z-score units, we find that the region actually has better scores in all three parameters, higher homogeneity and consistency and lower leakage. Similarly, if we consider the Inland North as the region characterized by the fronting of Lot, the Atlas benchmark for that is 1450 Hertz. The Lobanov transformed benchmark gets better scores. So it seems like Lobanov transformation does a better job at distinguishing the Inland North from other regions than the original Atlas benchmark does. Another example, the distinguishing feature of the broader North region in the Atlas is that it has a relatively back goat vowel. If we compare the F2 benchmark of 1200 Hertz to the Lobanov benchmark of minus 0.909, we get basically the same values for the isogloss parameters. On the flip side of that benchmark, the fronting of goat, which is used to define the so-called southeastern super region, the Lobanov benchmark of minus 0.909 is again about as good at distinguishing the southeastern super region as the 1200 Hertz benchmark is. So overall, I did this comparison for 14 different benchmarks with 3 isogloss parameters each: homogeneity, consistency, and leakage. That's a total of 42 parameters that I compared between Atlas benchmarks and the Lobanov transformation of those benchmarks. The full details of this are in the handout, which is linked in the YouTube description. So out of 42 parameters, only 10 of them are made worse by the Lobanov transformation of the benchmarks. So less than a quarter of them, which means, first of all, overall, in most cases, using Lobanov transformation on benchmarks does at least as well at distinguishing dialect regions from each other as the original benchmarks do, which were defined with that goal. Also, out of the 10 parameters which are worse with the Lobanov transformed version of the benchmarks, 6 of those are based on isoglosses that are internal to Canada, either the inland Canada region shown on this map or the Atlantic Canada region shown on this map. And those isoglosses and their parameters are calculated by comparing these regions to the rest of Canada, not by comparing them to the entire Atlas corpus. So in other words, these parameters are calculated based on only 32 speakers in total instead of 435 speakers. And so, I mean, I guess it's not that surprising that we have less consistent results just from a much smaller sample size. Also, so 6 of them are internal to Canada. Out of the 4 remaining that are worse with Lobanov transformed benchmarks, other than the ones internal to Canada, 3 of those 4 are worse by a margin of less than 0.02. So, I mean, overall, my point is, the Lobanov benchmarks seem to do about as good a job of characterizing Atlas dialect regions as the original Atlas benchmarks do, especially for benchmarks that are defined in the context of the entire Atlas corpus. Now, obviously, I'm not trying to convince you that Lobanov normalization is better than the Atlas normalization. Just if you're using Lobanov normalization anyway, and you want to be able to compare your data to the benchmarks established in the Atlas in a justified and replicable way, transforming the benchmarks in the way I've described here gives you reasonable values to use. By the way, I mentioned that the FAVE package uses Lobanov normalization, and it does, but it doesn't actually report its normalized measurements in Lobanov z-score units. It takes those z-scores and it scales them back into hertz. So for every speaker, what FAVE does is it sets the speaker's mean F1 equal to 650 hertz with a standard deviation of 150. And it sets their mean F2 equal to 1700 with standard deviation 420. So like this token here, whose z-scores are 1.37 and 1.19, those get transformed by FAVE into hertz values of 855 and 2201. Now, the mean and standard deviation that FAVE uses for rescaling F1 are actually the same as the mean and standard deviation of F1 in the Atlas corpus. So if you want to use the Lobanov transformed benchmarks that I'm proposing in this paper on data that was normalized in FAVE, you can actually just use the numerical values of the Atlas benchmarks unchanged in F1. But that's not the case in F2. FAVE sets speakers F2 means to 1700 hertz, which is more than 100 hertz larger than the actual mean normalized F2 in the Atlas. So for example, 1450 hertz in F2 in FAVE normalized data does not represent the same degree of fronting as 1450 hertz in F2 in the Atlas. So you can't just use the F2 benchmarks unchanged if you're working with the normalized output of FAVE. You can with F1, but if you're using F2 benchmarks, you're going to have to convert them or you'll get misleading results. Okay, so what we're looking at here is just the most important numbers from this talk. If you ever need to compare Lobanov normalized data to Atlas benchmarks, you can just pull up this YouTube video, skip to the end, and use these figures. You convert the Atlas benchmarks to z-scores relative to the Atlas means and standard deviations shown here, and then you use the z-scores that you get from that as your benchmarks. Anyway, the point is, The atlas set the baseline for our modern understanding of the dialects of North American English. And even as the dialects and their features continue to change, people still find it valuable to use the standards set by the atlas in order to contextualize newer data. And if you're going to do that, it's important to do it in a quantitatively motivated and replicable way that's meaningful for the normalization method you're using. Thank you.